Gente,
Okay, so good afternoon, all of you. I'm Shravan Kumar from Delta Technologies. Hello.
yes. Hello.
Yes, ma'am.
I think you can start.
Okay, ma'am.
Yeah.
Good afternoon, all of you. I'm Shravan Kumar from Delta Technologies. Today we will have a webinar on NetSim software. In NetSim, we can design and analyze. We can design and analyze various kind of network technologies like Ethernet, wireless networking, cellular networking, and WSN wireless sensor network, then cognitive radio, LTE, various kind of technologies we can design and simulate here. So first of all, why we use NetSim? You must be knowing that today we do a lot of research on various technologies like LTE, cellular networking, wireless sensor network, cognitive radio. So for analyzing these kind of network, very complex networks, we can't do it manually on paperwork. So we need a tool that will help us to design and analyze these kind of technologies and various kind of research. So that's why we use NetSim as a tool to help us in our research for in different areas. So there is a brief introduction of NetSim. This is a very popular tool in network designing, R&D, defense application, in which we can design various scenarios in different technologies like LAN, WAN, wireless, cellular networking, cognitive radio, LTE, and sensor networks. And we have an open architecture with protocol C source code, in which users can write their code and link it to the NetSim and debug it. So we have a lot of options available in NetSim. We can do designing through GUI, analyze the network, or we can change any protocol in the source code which we provide along with the NetSim, and we can edit those in Code Composer Studio, which has the link with NetSim. So these days, 300 plus customers are using NetSim for their lab experiment, research, and defense applications. It is being used in enterprises, R&D labs, and in academics, it is being used in network labs. In BTech, MTech courses, we have some network labs in different names. So we need these kind of tools in the curriculum. So we use NetSim there, and some projects and thesis work also we use NetSim. This is the architecture of NetSim. It has a CLI. It can be opened through CLI, command line interface, or GUI, graphic user interface. Then it will create a configuration XML file that can be edited further. And this is the internal architecture of kernels and virtual stack. After doing the simulation, we have some kind of data with us, like metrics, event trace, packet trace. These are the information which we got after designing on simulation in any network. Sorry. So there are some standards implemented here in NetSim, and we have different components for different technologies. Like in component 1, which is the base component required for all the other components. Like in base component, we have internetworks, in which Ethernet, ARP, wireless LAN, propagation shadowing, then IPv4, firewalls, routing, queuing, all these things are there in the internetworks. And these are designed on various international standards like IEEE 802.3 RFC standards, different standards. It is being designed, and there are some common modules like in applications. Like we can design a network and generate a different various kind of traffic on any node, like voice type, video type, FTP, database, HTTP, email. These kind of application we can generate on any of the node in any of the network. So then we have matrix engine, which can generate packet trace and event trace. Then packet animator is there, in which we can see our data packets flowing from one node to another. Then in component 2, we have legacy networks, which were used to design earlier. These are the legacy network which is being provided in NetSim, which has Aloha, slotted Aloha, PSMS CD, token ring, token bus. This kind of network we can design in legacy network, and it is being designed on the different standards like IEEE. Then in component 3, we have BGP networks, border gateway protocol. Then component 4, we have advanced wireless network. In this we have MANET and WiMAX. In MANET, DSR, AODV, OLSR and ZRP protocol is being used. And then WiMAX we have. Then in component 5, we have cellular network. In this we have GSM and CDMA both. Then in component 6, we have wireless sensor network and personal area network, PAN network. So for component 6, component 4 is required. So if you are using component 6, then MANET component should be there. Then in component 7, we have cognitive radio networks. And component 8, we have LT, long-term evolution. And component 9, we have military radio, TDMA link 16. So these are the components which are being used in different technologies in NetSim. So currently we are having 8.3 version of NetSim. So we have updated some of the parameters in different technologies. Like in LTE, OFDM for downlink is updated. Then SCFDMA for uplink is updated. Then MIMO for enhanced throughput. Then we have dynamic matrix as a new option, in which we can have the graph of application throughput and link throughput. When we enable this, we can have this application throughput and link throughput as a graph. Then UI property view. Then BGP and cellular with stack, GSM and CDMA both. Then there are some new application models added, peer-to-peer, email and HTTP. These are the various kind of traffics which we can generate in any node. Then NetSim is used for analyzing network, okay, and for modifying different network protocols. How, we'll see later. Then in modeling and simulation, we can see some GUI is there. There are some nodes available. These are the nodes which can easily be click and drop in our environment. And when right click, you can have the properties of your node. So it is very easy. And in the properties, there is an option of application type. In application type, you can generate different kind of traffic on any node, like voice, video, FTP, HTTP, peer-to-peer, email, custom. Okay. So this is the graphic user interface, which is first you will see when you open this software. Then this NetSim comes with two versions. One is academic and one is standard. So in academic, in standard, all the technologies are covered, but in academic version there is a GUI and analysis only. But in standard, you can customize your codes. you can customize your protocols, change anything in this in their syntax. So these are the analysis which are available in both the versions, in academic and standard. Like this matrix, when you design and analyze, when you simulate any network, you will have first thing you will have after the simulation is performance metrics. Performance metrics, we have network metrics, in which we can see the details of the whole network. Then in application metrics, we have the throughput. Then in link metrics, we have the information of all the links. Then in protocol metrics, we have the information of the protocol which are being used and what we have changed in our parameter settings, that will be seen. And device metrics, we have the information of the device, which are being what is happening in the device, we can see from here. This is Animeter. You can see some animation here. Some packets are moving from one node to another. So this is a packet animation player which is available in both the versions. You can change the animation speed from here, from slower to faster and faster slower. Then there are some analysis which are exclusively available in standard version only. Some traces are there. One is packet trace, another is event trace. In packet trace, we can see details of the whole packets, like on the different parameters like performance validation, statistical analysis, and custom code debugging. Then in event trace, records the every event on the different parameters. Different parameters like timestamp, event ID, event type, device ID, and protocol name, etc. Okay. So these are the exclusive parameters which are available in standard version only. Another is dynamic metrics. Dynamic metrics is the feature when you enable it during simulation. It will create some graphs of link throughput and application throughput. So we have option, we can draw this graph during the simulation or after the simulation. So when you click on during the simulation, it will slow down the speed of the simulation. So we'll do it after the simulation also. Then Wireshark you must be knowing. Wireshark is a real-time packet capturing tool which can be enabled or disabled on any node. When it is being enabled, then you can see some real-time packet capturing. And there are some internal features of Wireshark also, we'll see later. Then there is a development platform in standard version, which is being done in Code Composer Studio. Okay. There are two screenshots you can see. One is for programming. There are some codes available here, and it is GUI. So in this codes we can change something, and that will reflect when we do the simulation. Call that protocol through DLL file. Okay. For accessing this protocol source code, we have to go to the NetSim installation directory, which is available in program files in NetSim standard in SRC folder. And these are the various APIs which are available for protocol developers: packet.h, stack.h, list.h, graph.h, and IP addressing.h. These can be helpful in development of protocols. Then the software can be run through CLI command line interface or GUI. which will generate XML-based configuration files, which can be easier for understanding and better presentation. Then we have different customers which are using NetSim in their research and curriculum. Now we'll have a presentation of software in which we can see how we can design and analyze different networks. Okay. First thing you will notice on opening the network, opening the NetSim is this window. Okay. So we have simulation. In simulation, we have different technologies like internetworks, legacy networks. In internetworks, we have wired and wireless network both. Then in legacy network, we have pure Aloha, slotted Aloha, traditional internet, then token bus, token ring. All these we can design in legacy network. Then advanced wireless network is there, in which we can design MANET and WiMAX networks. Then BGP network is there. Cellular network, wireless sensor network, PAN network. Hello, Tejas sir.
Yes.
Uh,
Yes, Shravan.
yeah, sir. I just do a presentation, and after that we'll have a discussion session. We'll discuss all these things in there.
Yeah, sure.
Okay. Thank you. Then these are technologies in which you can simulate. Then programming portion is there, in which there are some sample programs, and there is a option of editing those programs and design your own exe files, and you can link it with NetSim. Then utility, you can act as the admin and you can give the rights to the users how they can use this their experiments. And help is there. NetSim user help, source code help, and experimental manual. All these are in PDF format. Like in simulation, when you have to start a new simulation, you have to click on new and enter networks, like design inter networks. Here is the environment of the software. Here you can drag and drop these nodes. Like in node, you will see wired node, wireless node, then UE, WiMAX. These are some disabled nodes which are available only when you select those technologies. Then it will be enabled. Otherwise, it will be disabled. So in internet network, these nodes are enabled like wired and wireless, switches, router, link, access points. So we just drop some of the nodes here. Some switches, then routers. Then we can link it with wired link. Okay. So this is a network, wired network. We can combine one wireless network through router uh, by clicking an access point, then connecting some wireless nodes. Router to access point, it will be a wired link. Okay, so these are network. You can see the properties from right clicking on any node. Here are some global properties, and you can see the node name, device type, and its position. Then we have Wireshark. You can enable or disable Wireshark from here. If you enable it, it will run during the simulation. Then in transport layer, we have TCP UDP protocols, and there are different parameters which you can edit. And there are some information tabs given here, in which when you click on this, you will have the information of that tab, the definition of that tab. Okay, you can click and see the information tab. Then network layer is there. IPv4 protocol is being used. Then interface of Ethernet, in which there is a IP address, subnet mask, default gateway. Then data link layer, physical layer. All these are parameters which have been given. Okay. Now we can send some traffic from one node to another by dropping this application tab and right click on properties, and let's say we send some packets from 1 to 10 node. Okay, and this is the application type in which we can send these kind of traffics on in any node, like in CBR, custom, email, HTTP, video. Okay. Custom, email, HTTP, video, voice, database, FTP, all these are kind of traffic we can generate on any node. Send some traffic from source ID 1 to destination ID 10. Okay, we can change the packet size, their distribution, either it is constant or exponential, or inter-arrival time also. The size of the packet and the arrival distribution, both we can define from here. Okay, so we just accept it. Or we can see the link properties also from here. Like this is a wired link. You have the link type, link medium, link mode, and maximum uplink speed is there, downlink speed, uplink BER, downlink BER. All this information we can select from here. You can do it to no error. Okay. Then wireless link we also see, like link type, link medium. Then channel characteristic we can change from fading, shading, fading only, line of sight, or no path loss. When you select no path loss, it will. Likewise, we have different properties for different different nodes. For router, the router properties. Now we have seen in the presentation that the standard version has some exclusive feature like packet trace, event trace, and dynamic metrics. So when you click on packet trace, it will ask you a file name. Okay, these are the attributes which is being selected, and it will show you the result according to that. So you just click on OK. Likewise, it has event trace. You have to give the event trace name, and these are the various attributes on which the result is being done. Okay. Then we have dynamic metrics. Dynamic metrics, you can see the graphs of link throughput and application throughput. Okay. So we have a plot graph after simulation, because during simulation it will affect the simulation speed. So we'll select the graph after simulation. Click on OK, and we can run the simulation. 20 seconds, and there is an option of recording the packet animation, play and record both, and don't play record. Okay, So we have to see the animation, so we'll select the record animation, click OK. We have selected the Wireshark, so it will be opened during the simulation. The Wireshark is being initialized and it will capture your packets while running the simulation. Okay. Here you can see the TCP packets are being captured during the simulation because simulation is running now. The packets are being captured during the simulation. The simulation is complete. It is creating the graphs, dynamic metrics. Now after the simulation, we'll see the performance metrics. In this network metric is there, in which we can see the parameters, the result of all the network, like simulation timing, packets transmitted, packet errored, packet collided, and bytes transmitted, payload transmitted, overhead transmitted. These are the details of all the network. Okay. Then likewise we have link metrics, which we can see what is happening in the links. Two metrics. These are the common attributes which are available when you do any kind of simulation. Okay. Then we have application metric, in which we can see the throughput of the whole network. Then we have dynamic metrics. We have enabled dynamic metrics, so the graphs will be available for all the links: link 1, link 2, link 3, 4, 5, 6, 7, 8, 9. All the graphs. Okay. Then there is a graph of application throughput. We have customized the application. So the graph is there. Now in view packet animation, when you click on play, you can see a packet is moving from node 1 to node 10. When packet 1 node 1 receives the acknowledgement from node 10, then it will send a custom type of packet. You can see in green line, custom type of packet is being sent from node 1 to node 10. You can increase the speed to see the packet animation faster. Okay, now you can stop and see other parameters. Like we have enabled packet trace and event trace, so we can see open packet trace and see the details of all the packets given in the Excel format. All the data of the result can be exported to MS Excel CSV format, and then later we can analyze through graphs or inserting any graphs, line graph, any kind of graph. Okay. So these are the various kind of parameters of packets which are being generated after doing the simulation and enabling the packet trace. Okay. Complete packet trace is there, one by one. Likewise, we have event trace. Here is the event trace, which we have the details of all the events performing in the simulation. on different parameters. Okay. So all the data after the simulation can be exported to the MS Excel. When you click on export to msexcel.csv format, it will give you all the result in Excel format. Then you can insert the graphs and analyze all these parameters. All the result would be in Excel format. Okay. So these are the various kind of parameters which are available after the simulation. Then we have Wireshark. In Wireshark, there are also some features in which we can see some graphs like conversation. Go to the TCP. You can see some graphs. Graph type you can change to RTT, round trip time, throughput, and time sequence, and window scaling. All these parameters we can see there. IO graphs are there. Here you can set the different parameters like IP, ICMP. Different graph you can enable. You can change the tick interval to 0.1. Here you can see the graph. On different parameters you can see the graph. Now we go to the next thing. Just save it. Now there is the option of go to NetSim Analytics. Click on this. Go to the another window, NetSim Analytics, in which we can see there are various kind of technologies tab given here. Like if you want to see the comparison of different experiment on different parameters, you have to browse those metrics file from there. Open one of the files. Then browse some of the ready-made experiment I've made. Open the metrics file. Now we can see the 4 metric file we have, and we can see various comparison between simulation timing, packet transmitted, packet errored, packets collided, bytes transmitted, payload transmitted, overhead transmitted. So this is the analytics tool which is available in NetSim to compare various results by changing various parameters in different experiments. Okay. Likewise, we can analyze other networks like LTE, legacy network, BGP network, MANET, various network. We can analyze from here. Okay. Then we'll have some sample programmings given here, like ARP, assignments of size2 concentrator, cryptography, DVR. Like in cryptography, if you choose substitution, we'll have 2 environments, one in this mode in which we can choose sample and user mode. In sample mode we have some ready-made programs given here in NetSim. There we can choose and analyze this result. Like if you click on this, write plain text and give a text 3 and run, it will run your program according to the codes given in the backend. Okay. Then For doing the decryption, you can click on run. It will decrypt those data. You can refresh. Then when you want to create your own code, you have to go to the user, and it will ask you a exe file. That exe file can be created by clicking on interface source code and edit those source code, and by saving it in exe file, and you can link it here in NetSim. Okay. Now I've told you that standard version has a custom code facility. Okay, custom code in which we can edit our protocol in Visual Studio. Like if you go in the installation directory, you have bin, docs, src, these folders. In bin folder, you will have all the DLL files of different protocols. So the NetSim access these DLL file, and then call this DLL file and run the simulation. So we have to put our DLL here in the bin file in this format only. Like here libdsr.dll is given, so you have to give the libdsr.dll file only. So when you click on NetSim standard, there is src folder and there is simulation. When we click on simulation, you have to click on this simulation tab, and we'll have all these protocols as a source code in the Visual Studio. Like I've opened it already. There is a DSR protocol I have given here, DSR protocol, in which I have entered a command printf hello world program. Okay. Printf hello world. So when we run the simulation after building it, then our DLL file would be made, libdsr.dll file in the DLL folder. In DLL folder you can see libdsr.dll file is there. After building it, I've already built it, so it is there, and copied it into the bin folder. So this is my libdsr.dll, which is being edited with the printf hello world program, and I have made original DSR file as a libdsr default.dll, so that my original DSR protocol would not affect after doing any error in my dsr.dll file. So when we call this DSR file now, it will work our hello world program there after the simulation. Let's see. Let's open one manage program, and here we call the DSR protocol. We have set one CBR packet from 1 to 5. Here we can run the simulation. When we run it, then this CMD window appear, and you can see this hello world printed here. So it will stop your simulation in between and print this hello world program. The init function enables this hello world program, and when you until you enter the enter key, it will stuck to the hello world print hello world only. So when you click on enter, it will run after this. Okay, so there is a way to show you that we can change in the protocol. So I just edited it by giving a command hello world, so that we can see whether we can change something or not. So the procedure is same for doing any simulation. You can see the packets moving from one node to another here also. Okay, so we can change the simulation speed from slower to faster. There we can see the nodes are changing the position also. So all the parameters are same. The result would be according to your parameters given in simulation timing. Okay. Likewise, we can design any network in inter-network, legacy, advanced wireless. All these network we can design. Okay. Like open network. There is a small wireless sensor network given here. Run it. It has some parameters. I mean, node-specific parameters are there, which will affect your simulation when you change these parameters here, like power, sensor range, sensor intervals. And these are some of the parameters which are node-specific only. Sync node parameters are there. These are according to the nodes available. We just run the simulation. So it will, it is calling that DSR protocol here only. So it will print the hello world because our DLL is there, which we have edited. So we have to give the command enter, then it will complete the simulation. Okay. So this is the complete flow of doing any results, any simulation and analysis. We can change the technology, we can change the protocols and do the simulation like this. Procedure is same. We just have should have some parameters which can be run so that our simulation can run properly. So now you can ask your queries. If you have any queries, you can ask.
Hello.
Yes, ma'am.
How it will be differing from the Qualnet?
How it is different from Qualnet?
Qualnet is
Yeah.
no. In Qualnet also we have the same features. Wired wireless network we are having.
Yes, yes. For that, I'm referring Pranav sir. Hello, Pranav sir. Hello.
Hello.
One second.
Yes, hello Shravan, this is Nirj here.
Okay, Nijar.
Yes.
Yeah, there are some queries from the faculty.
Yes, just give me 1 minute. Just
Yeah,
1 minute.
Okay, okay.
Hello.
Yes, sir.
Yes.
Yeah. See, regarding the difference between Qualnet and NetSim,
Oh, yeah.
the first main point is that Qualnet's licenses are annual, so it will only work for 1 year. All licenses of NetSim are perpetual, so there is no time limit, and it works forever.
Mm-hmm.
The second thing, technically, Qualnet doesn't have libraries on cognitive radio, then on wireless sensor networks in which we have leech. There is no intrusion detection system, there is no sinkhole attack. Then there are no libraries for some of the cellular protocols. So we have a slightly wider range of protocols in NetSim compared to Qualnet. Third thing is that we give this, as you saw, this packet trace and event trace facility, which helps for R&D purposes. Qualnet doesn't have a detailed tracing module. So our product is actually more suited for R&D, and Qualnet is more of a product that was typically that's used for more defense and core network modeling kind of situations. These are the broad differences.
We can get this software, sir.
Yeah.
Yeah. This software through Dellsoft, you can get the software.
Ma'am, we'll send you the details regarding commercial detail. We'll send you on your mail.
Okay. We can take it, right? Software for usage purpose.
Okay. Okay. Any other queries?
Hello?
Yes.
Yeah, I think earlier Mr. Tejas Bhatt had asked about this vehicular
One
ad hoc
query.
network.
Yes,
So to add to that, the point is simple. If you take our MANET and if you change the mobility model similar to one of vehicular motion, and I mean with just that you can get a vehicular ad hoc network because it supports up till very high velocity. So you can just change the icon to give it better visualization. Then you can load it on our map view. So there's an option for you to run it on a map. And then if you set your mobility model similar to that of a vehicle, then you will be able to exactly view how the vehicular network would behave. And regarding recorded video, there is recorded video of this will be sent also in our channel. Rajesh ji has pointed out there is number of videos that are there which users can view at any point of time. So it covers the basic networks plus add-on modules like leech, intrusion detection system, sinkhole attacks. Then we have channel bonding in cognitive radio. And there itself there'll be links to our file exchange where you can see the documentation and source code as well.
Hello?
Yes, ma'am.
You have said we can compare all experiments now, Shravan.
Yes, ma'am.
There we can have the difference of wired and wireless also we can compare.
Wired and?
Any type of wired and wireless. In some parameters we can compare that also.
Yeah. In the analysis, you just have to load up the metrics file. So if the metrics is an output of a wired network, it will take that. You can compare wired, wireless with LTE, with cognitive radio. Between any set of experiments, the comparisons can be done. So our metrics is all the metrics within one experiment. But if you want to compare across many experiments, you can do that in the analytics section.
Actually, I've combined both the wired and wireless. So we have to separate, make the wired network and wireless network, and compare those metrics. Any other query, ma'am?
Yeah, no, thank you. It was very useful.
Okay. Thank you, ma'am. Okay. Okay, any other query? Do you have any other query, or we can end this meeting? Hello?
Hello?
Yeah, is there any query, ma'am? We can call.
Yeah, no.
Okay,
Okay.
thank you. Girish sir, hello? Okay, then we'll end this meeting. Huh? Thank you. Thank you very much.